Hi, everyone. Welcome to this special MLOps Program Webinar. Today, we'll showcase an impressive Capstone project completed by a team of recent graduates who continue to build out AI technology that can help protect our planet's forests. Backed by the Andrew Ng's AI Fund, Fourth Brain develops cohort-based courses for a global community of data science and machine learning professionals like you who want to future-proof themselves against the next wave of AI and automation technologies. End-to-end MLOps represents the tip of the spear for machine learning in production, and the capstone you'll see demoed today came out of our last cohort of the MLOps program, which is designed specifically to help you become an end-to-end ML practitioner, the kind that every company needs to win in the market today. Before we meet the Capstone team, let's meet each other. Our global community continues to grow thanks to you, and we encourage those of you joining us today live to leverage Fourth Brain to start creating value for yourself and others by building relationships amongst the other ML practitioners in the audience. Let's share who we are, what we do, and where we're tuning in from in the chat. I'm Greg Loughnane, Head of Product and Curriculum at Fourth Brain, and I currently live in San Francisco. What do you do? And where are you located? Let's keep the intros coming in the chat as we go ahead and get started. Today's session will serve as a sneak peek into what you could accomplish in just 10 weeks during our MLOps program. You'll see what a functional AI product looks like, and will receive a public link to try it out yourself. You'll also get access to the GitHub repository that contains all of the code required to build and run this application. We will share links with you directly in the YouTube chat throughout today's presentation. After we hear from our speakers and see their demonstration, I'll follow up with a few questions before we open it up for audience Q&A. So if you hear or see anything that you'd like to ask about, just drop your question directly in the YouTube live chat and we'll get to it. With that, it's my great pleasure to introduce the @Forestry team of Martin, Borja, and Yanni. Martin Moreno is a senior data scientist at Marsh McLennan and is based in Bogota, Colombia. Borja Gomez is a serial entrepreneur, CTO, and general manager with experience working in Silicon Valley startups, including one for which he was a co-founder that received venture funding from Sequoia Capital. He lives in Barcelona, Spain. Yanni Aziz, also a serial entrepreneur and CEO, has had multiple startup exits throughout his career and is currently based in Tel Aviv, Israel. Guys, go ahead and take it away from here.
Hi all. Okay, I will start. Somebody has to. So we are really excited to be here. It's our first live streaming event. And Greg introduced us. Basically, just a couple of words on each one. So my name is Yoni. As Greg said, I'm an entrepreneur. And about 2 years ago, out of curiosity, I joined the AI research group for innovative machine learning algorithms. And this led me to think of how to implement MVP and deploy end-to-end machine learning. So I joined the Fourth Brain, MLOps. I came with very little background on DevOps. So it took some serious effort to catch up, but it was worth it.
And hi, in my case, my name is Borja Gomez. Well, I'm an IT engineer and MBA. I started my career at P&G in the interactive marketing department. But in 2004, I started also entrepreneurship. I started companies in Barcelona, in Singapore, and now in California. And yeah, I really joined MLOps course because I really believe the data-centric approach that Andrew Ng is pushing forward. And I have experience in DevOps, so I thought I could leverage that experience and bring value to ML. So glad to be here.
Hi everyone, my name is Martin Moreno. I'm a senior data scientist. I have 5 years of experience, mostly on the insurance and finance industry. I think I joined the MLOps course because I was much more involved on the data science side of the artificial intelligence space. But as many of you, I think I was having some trouble trying to like build some models, but actually convert those models into products, right? Like real artificial intelligence services. So concepts like Docker, Kubernetes, like all of these things, I didn't know how to use them. So really like this specialization enabled me to learn about this and break the gap that we were having with regards of trying to deploy and really convert products with the models that we were developing. So with that in mind, maybe Johnny, do you want to take a brief introduction and then we can take it from there?
Let's start. I'll share a screen so we can see some slides. Well, at Forestry, what the idea is all about, it's to take the power of machine learning to protect our planet's forests. Now, global warming is an issue, the greenhouse effect. We know the environment is an important thing, and undoubtedly, keeping the forests and monitoring the forest is a very important issue. But before we start really deep diving into the Capstone, I want to show a slide about our team. Greg presented us a little bit, but he didn't say that actually we built all the MVP end-to-end, fully working product just in 18 days. And this was because Borja and I joined Martin on very late stage, almost when the course was finished. And we had 18 days and we made it. And when you look on the triangle, on what I shared, I'm working from Tel Aviv, Borja from Barcelona, Martin from Bogota, different hours, all of us have work to do, except this, and we came from different backgrounds. So how did we do it? Basically, I tell you, and this is something that I hold in favor of Fourth Brain, it's because our team had chemistry. And actually, the whole cohort had great guys, but the three of us, we had such a nice chemistry. We became friends, and we were talking to each other, brainstorming with each other, each one taking from his experience. I mean, I have a math background. I was talking about the models, Martin as a data scientist, and Borja with his DevOps experience. And we were all the time brainstorming and working as a team. A great team is something that is, it's an asset. And we got it. We were lucky. We were lucky to have the chemistry and become friends. So that's what I wanted to say about the team. I think now we can start with really talking about the Capstone. And for that, it all starts with scoping. What is the problem? What we want to solve? How do we take a machine learning model? How do we take the right data? How do we pack it all? And I want us to look into this through the eyes of Martin, because he came up initially with the idea of the environment. So Martin, please take it from here. I will stop sharing and please continue on the scoping and data and model.
Sure, thank you. Thank you, Johnny. Let me just share my screen. So as Johnny was mentioning, like when we were talking about the scoping, it's also very important, I would say, one of the most important things of defining or starting to work on this project is really understanding what is the problem that you are trying to resolve, right? And really trying to see if it is something that is worth of spending some time and hopefully something that makes the world a better place. So in this case, I think that most of you should know that global warming is a real issue right now. And I think we can just see these images without having to explain that. And even, I don't know, like Borja, can you tell us like what is the weather right now on Barcelona?
It's a top right corner, right? I think in non-Mediterranean. So I think John is also going through this.
Tel Aviv is the same. We are living in the aircon.
So yeah, like there is no question that like we are facing a major climate crisis, and I think we should try to start using technologies like artificial intelligence to try to do something about this. And we're not going to get into much detail into numbers and all of that, but the message that I want to send is that there are like some policies that our governments have put in place for trying to address this issue, but they are not enough, and we need to help with some contribution.
I take it from here. Yeah, we couldn't hear you, Martin. So I'll take it from here. Sorry, guys, for these technical issues. So yeah, definitely one tool that we have in order to fight this climate change issue that we have is reforestation. And the main reason why reforestation is critical is because it sequesters CO2. So we take CO2 from the atmosphere, and I think most of you are aware of this. But we really want to make sure that this is really important, no? to manage the CO2 that is in the atmosphere. There's one very important problem with reforestation and making sure that the measures that governments and even companies are putting in place are effective, and is monitoring the reforestation. So Martin, if you can go to the next one. So right now, this is a very manual process. You have to bring people to the forest. You have to do physical inspections. It requires a lot of time and resources. I think you're back on, right, Martin?
Yes, I'm back.
All
Sorry
right.
about that. Perfect.
No.
Yeah, sorry about those technical issues. Yeah, as Borja was saying, deforestation, the monitoring component is very hard because it's very manual. People need to actually move into the field. They need to spend resources on time and on a lot of time and having to travel to the specific areas that are protected. So when we started to brainstorm on what we could do, we said that, yeah, like maybe we can use a tool with some technology and internet to monitor, like to scale up the monitoring process, expand the coverage area, like not only having to go to a specific place, but being able to like take the data from maybe a satellite where we could take some images from the surface and monitor a lot of areas, and also enable this tool to be used from everywhere in the world. So how we started to scope the solution of this project was, I think we could train a convolutional neural network or specifically a computer vision model for trying to detect this deforestation. So we divided the solution in two parts. The first one, again, like a convolutional neural network for being able to predict the type of coverland that was seen from these images. So for example, if you could see, well, like here are some examples, like cloudy, primary, if we had some forest, primary with agriculture. So that was the first step. The second step was to build a detector to compare these labels at different point in times. So in that way, if my first snapshot that we took, for example, a year ago, was creating a label of fully primary, but for example, if we did the same scanning at 1 year later, we are starting to see not fully primary, but agriculture primary, like in the example down below, then we were having a deforestation case. So that was kind of the design that we put together for this project. And then just talking about the methodology that we used and where did we get the data, we were very lucky because actually Planet Institute with Kaggle run 5 years ago a competition that was aiming to actually resolve that first part, right? Like being able to predict these labels. So we had a lot of information about these geotiffs already labeled for us. And as this was a competition, all of the solutions were open source and were available for us to have a look, to look at the GitHubs and actually implement very fast the code. So we used the data that was collected from January 1st, 2016, 2017, and this was covering the entire Amazon basin from Peru, Colombia, Venezuela, Guyana, Bolivia, and Ecuador. And this was the data that we use. But now maybe Johnny, like, do you want to take it over to discuss a little bit what were the values that we framed for the project? I think you're muted, Johnny.
Yeah, we are newbies on this live streaming, and luckily the team
and we
is
made
helping
two
each
dry
other.
runs, eh?
Yes,
we made 2 dry runs, man.
But at least we are spontaneous and we help each other. You can see the chemistry of the team. Yeah, well, what I was starting to say is that we go back to the scoping and we ask what value such an idea can bring to the table. And luckily with that at Forestry, there is both monetary value and there is intangible value. The monetary value comes from the fact that the carbon credit market is a hot topic. If a few years ago, 3-4 years ago, it was a market of $50 million, $40 million. Right now, it's exponentially growing to become a market of $100 billion. And carbon credit quotas can be traded. So when you have players trading in this market, they need information. And information like where deforestation is happening, reforestation is happening, that's information that gives players an edge. So we can monetize on that. It's something that definitely brings monetary value. But on the intangible side, at Forestry is really an important project for the planet. There is all the time a ongoing activity of auditing and monitoring of reforestation, deforestation. There are NGOs involved that can benefit from having the information, what's going on the planet. And basically, on the bottom line at Forestry is a small contribution to assist our planet to handle the CO2 levels. So by wrapping up the scoping, I want to continue to how we built the MVP. Like I said, it's an end-to-end MVP. So we had 18 days. That's not a lot of time. That's a little bit more than 2 weeks. And we chose a collaborative tool, a tool that we can collaborate, brainstorm, put our stuff inside, and then start coding. And the tool that we chose is Miro. Probably a lot of you have heard of it. And there we started putting the things that we want later on to code or to implement. We chose a microservice architecture. And we did 2 things. We knew that since this is a machine learning, we want to show the whole pipeline. We want to deploy the whole pipeline of the model with the tools, with MLOps tools. And we chose Kubeflow. And then when we jumped to the end-to-end solution, we took the approach of looking how the end-to-end will look with CI/CD, continuous integration, continuous deployment. Again, with the microservices architecture that we decided to define, and we Dockerize everything, use Kubernetes. Borja will explain in a minute more about that. But just to give a few words about the Kubeflow, about the MLOps model pipeline, there are so many new tools coming in recent years, and in Fourth Brain, we were exposed to a lot of them, and we had our cloud accounts, and we could experiment, and it cost quite a lot of money because, for example, for our project, like Greg told me, you can do whatever you like. So, we took 8 GPUs and 30 CPUs, and we were experimenting, and it was a lot of fun. But let's go to the final product, to the end-to-end MVP, and Borja, take it from here.
All right, thank you, Johnny. So yeah, I'm going to show you the final product. I think there's the link to the MVP is going to be actually shared on the YouTube chat box, but I'm going to show you, let me see if I do it right. Yeah, so this is the URL actually. Yeah, there you go. Can you see the screen? I guess so. So this is the URL to the final MVP. It has a domain name. It's like really end to end. And this is the beauty of it. I mean, we took
Borja, you're sharing the other screen.
Oh, I'm sorry. You see, I had to do something wrong as well to be
now consistent. It's the three of us. It's the three of us. We all messed up.
There you go. That's the one. So I did it in purpose. No, I'm joking. So this is the URL. You can actually go right now. I mean, it would be nice to see if all of you go to it and see how the infrastructure holds. So yeah, this is live. You can play with it, etc. But I'm going to show it to you anyway, nevertheless. So this is at forestry.com. Right now, what you can see here is part of the Brazilian basin, or the Amazon basin. This red area right here is the area that we're currently monitoring. And then right here, what you're going to see when we click inside this red area, you're going to see a moment in time zoom in of this area with 2 moments in time. And it's going to compare both moments. It's going to see if there's deforestation or not. This doesn't look very big. You can see it's kind of in the east of the Amazon, but this is actually 380 square kilometers. So if you click in any of the area, let's say I want to check this one, it's going to show you this zoom in. This is last month, June 1st, 2022, and this is this is actually 2 months ago, and this is last month, July 1st, 2021. You can see there's no deforestation. There are some areas that have no forest, but it remains the same. If I click in another area, for example, you can see here clearly that there's some deforestation, and the algorithm is able to see, hey, there's new developments here. Maybe there's agriculture, there's mining, etc., that they were not 1 month ago. So yeah, we're able to determine if there's deforestation or not. It's actually very interesting because if you click on many of these areas, it's very nice to see that there's not many areas with deforestation in the last month. So something is going all right, at least in this part of the Amazon basin. Okay, so I'll go back to the presentation. And one thing that I really learned in this MLOps course, and I really enjoy again, is we work first with this diagram of the architecture. This is critical for us to be fast because we have to agree on many things. And the first thing what we learn is that typically an application is the Kubernetes. You have your microservice architecture, your database, maybe you have your messaging system like RabbitMQ or something like that. But then when it comes to ML, there's there's a new person in the team, which is the data scientist. And we also need to make sure that this data scientist or this team of data scientists can work very well together. This is why we decided to create this top part. This is like a dev stage for data scientists, so they can experiment with models, with new versions of data, etc. And then how these two blocks interact. This is something you're going to learn in MLOps if you apply. This was really exciting for me because I wanted to. This is a big difference. And then the other difference is this monitoring of the models. Usually when you deploy an app, it works and that's it. And then you just track, you track the dollars, let's say, I don't know. With a model, you have to see how the model is performing online, because you never know if the data is going to drift or there's going to be a model decay because the models cannot be valid anymore. So there are a few elements that I learned throughout the course that was really, really interesting. I'm going to go specifically to some of the microservices for you to know what's behind the scenes. So the first microservice, and it's really important, is fetch data. This is the model that is taking the data from Planet API, pre-process the data, and does the prediction and stores the predictions. This is a batch inference, okay? So we decided to do this because all this process usually takes around 6 hours, so we couldn't do online inference. So the first thing is, there's a microservice called batch run, where it's configured how many times we're gonna call this microservice that calls fetch data. Fetch data, the first thing it does, it takes the images, the geotiffs. It's a TIFF image. It's depending on the red square. Let's say we're going to have more or less, and then we convert those into PNGs so we can fit them into the model, and we send them to the microservice of model predict. Model predict is gonna give back the predictions. It's going to return the predictions, and we're going to store the predictions in a database for online query. And it's going to store the PNGs into Google Cloud Storage, so we can load them later on the front end. Regarding the model predict, we try and we didn't make it, and maybe this is something to extend in the future, to connect Qflow with this microservice, because you can do model serving from Qflow, and then this microservice wouldn't need to know what's the latest version of the model. We just ask Qflow, this is my PNG, give me the prediction. We didn't make it, so what we did is we used DVC, the data version control. This is something that you're gonna hear about it if you already didn't so far. And we store the model registry, let's say, is Google Cloud Storage, and we use DVC to get the latest version of the model. And later the front end. So all the things that you saw on adforestry.com is based on Vue.js. And then this Vue.js, what it does is it's basically sending the latitude and longitude where you click to an API, to a microservice here, API@forestry.com, which queries the Postgres to get the predictions, and then it loads the 2 images, and API also calculates whether there's deforestation or not. Okay, so all of this, there's a lot of things going on in the background, although the MVP seems simple. One of the challenges was Martin worked very hard during the initial part of the course to create these notebooks. And then the challenge was to transform these notebooks into a production MVP. And this is actually what MLOps is about. This is actually what it's about. No, we have a team of data scientists creating models and experiment, and then how we did it. And doing it in 18 days was quite a challenge, as Johnny said before. So we had to do certain things in order to speed up the process, the development process, and make sure. One critical thing, as I said before, is the diagram. The other thing that actually Johnny was responsible for is to make sure that the infrastructure is created with infrastructure as code. So the infrastructure is managed with code, with a single line of code. You can actually spin up the infrastructure in a Kubernetes, and we could change microservices just changing the code. I have the repository here. You can also access this repository online. It's public, but you can see here, for example, there we have one repository called infrastructure here. And if I go to this repository, I'm going to click on the makefile. We create a simple makefile that, if it loads, there you go, where, for example, this command, create infrastructure, it spin ups everything. And we actually had to change to another project because the resources from MLOps stopped, and we were able to put up all the MVP in just 2 hours. We had some issues that we had to work after that, but basically it was everything spin up in less than 2 hours. We reviewed everything was fine, etc. And the other advantage of infrastructure as code is that you have all your microservices, definition of the pods, of the workloads, etc., is documented here. So let's say, I don't know, how did we create the workload for the API? Well, you have all the definition right here. So you know what were the resources we gave to this machine. You know what is the vertical scaling of the resources, etc., etc. So you don't need to ask, you don't need to document. It's already here. So it has lots of advantages. The second thing we did is the local stack. So all the microservices are Dockerized because they need to work whether in local on the front end. But we also created a local stack in order to be able to replicate the Kubernetes in our local machine, because that's important as well. So basically the local stack is a big Docker Compose file where you run it and you have all the microservices infrastructure running in your computer, and you can develop it locally, and you can develop a lot faster with it. All right, so that was really critical. That was one of the critical things in order to develop faster. You cannot develop sometimes microservices independently. And the third thing we did is the boilerplate, and that's something that we were thinking. Okay, I don't have experience in Python. I had to learn on the way. And Martin maybe doesn't have, or Johnny doesn't have the experience on Docker Compose. So it was tough. How we make it that we start microservices very quickly. We also use the same setup, the same configuration. So if I have to move to another microservice, I know exactly where things are. So we decided to create this boilerplate template. This is a template where you create a new microservice. You just use this template, and it has everything you need. You don't need to worry about all this crazy DevOps stuff like the Dockerization. You even have an initial implementation of Fast API. So you just copy this template. Here it goes. And you just copy the template and you start coding. You don't need to worry about Docker or pushing the, CI/CD was implemented as well, so you didn't have to worry about it. So there's a lot of things going on here that you don't need to worry about. So that was also critical. So just for you to see how simple it is, let me check that just for a second. So if I'm a developer, I want to start a new repository in the platform. A new microservice, sorry. So I just go here, new microservice, and then I use this template, the boilerplate template. There you go, at forestry, and that's all. It's everything there. I can start coding from minute one, and it will work. All right. So that was another important aspect for us to be able to complete the MVP in just 18 days. All right. So more or less, this is what I have to say about technology.
Perfect, Borja. Thank you. Yeah, and like diving a little bit more on what Borja mentioned about the boiler template, I think really that one really enabled us to deploy and to iterate very fast. Because, for example, an example like more on the data science side, I think you have experience that somebody is training a model and it works, but then you try to take that GitHub, you run it, you build the content environment, and all surprise it doesn't work because this was done in a virtual machine, you're in a Mac and the other person maybe is on Windows. So this boiler template, actually, you can use it for these type of things, right? Like you can enable a template to run like a Jupyter notebook inside of a Docker container. And if you run it in there, you can be sure that whatever is trained in there, it's going to be trained on my laptop, any virtual machine. So this was very, very interesting. But now, like just making sure that we are on the same page on the problem that we were trying to resolve. Sorry, again, like we had some technical issues. Like what a forest is trying to do is to monitor deforestation, right? And the thing is that we believe that sequestering carbon from the atmosphere can be done through forests. So reforesting is not the only solution for the climate change that we're experiencing, but definitely it helps. So this is what we try to resolve with that forestry. So one of the biggest questions that we had after finishing all of this amazing experience with WorldBrain was, okay, so what is next? What are we gonna do with this? So there are like some pending tasks that needs to be developed, right? Like this was an MVP and it has to be built very, very fast. So the first one is we need to improve the deployment, right? Like we maybe need to implement something like Kiev serving or NVIDIA Triton server to really take advantage of these frameworks for servicing the models. we need to really scope and improve the scope that we are providing to at forestry, like maybe talking to some industry leaders. The modeling part, like again, like we based upon a lot of implementations that were done on that Kaggle competition 5 years ago. This is a VG16 architecture, and I'm sure that today we could be relying on maybe ResNet or some transformer architecture that we could use for getting like much better results. So there are a lot of things that they still need to be done, right? So what we would like to announce in this space to everyone, and maybe let me just share my screen one more time, and hopefully we can make it right this time. Yeah, like we would like to announce that we want to give at forestry to fourth brain, right? Like to all of you that are listening to us today, this is an amazing capstone project that we want to keep it alive. We want to keep contributing to it as an open source project, but also we have decided to offer this project to the fourth brain upcoming MLOps cohorts, so that if you are planning to join this cohort, you can reach out to us and take the lead to continue the development on that forestry project, right? Like this is a good project, it's making an impact on the environment. And yeah, like Johnny, Borja, and myself, we commit to help you during the path. And if you need like any technical support, we will be helping you to go through this implementation. So with that in mind, I just want to say thank you to Greg and to the entire Fourth Brain team for having us today. And again, yeah, like excuse us for these technical difficulties that we had. And yeah, Greg, back to you.
Thank you so much, Martin, Borja, and Yanni. Really enjoyed that presentation. That's so awesome that you guys are really pushing this forward into the future, and we're really excited to work with you on this. You know, Borja, that was an amazing set of live coding that you just gave us as well. You know, I think everyone really appreciates that in our audience. So I want to go ahead and just get right into the audience questions today. And maybe we can start with the stack that you showed us, Borja. Dukes says, please, can you give a list of all the applications and tools that you used in this end-to-end process? Putting you on the spot here. I know it's in GitHub, but can you give us a quick overview of what you kind of used in your stack?
Okay, let me see. If I start with infrastructure, so we have Kubernetes, Google Cloud Storage, and then, well, basically that's it, at least from that point. And then for the development of microservices, we use Fast API with Python. We use Docker for Dockerization and Docker Compose. We also use Postgres as the database because we had to store all the predictions. DBC for the version control of the model, and Vue.js for the front end, and engines to serve the Vue.js actually. So yeah, there's a lot of variety of technology.
GitHub Actions, Borja, GitHub Actions also.
You see, I was missing something important, and also for the CI/CD GitHub Actions, I think, which works great, by the way. I really recommend it. So yeah,
TensorFlow, right? TensorFlow, which is the heart of everything.
Right. It was a difficult question, definitely.
Let's not forget about the data science. Yeah. Well, so I think that dovetails well into another question from Kumar Raja that says, sort of, what percentage of MLOps is actually DevOps work? What would you say? Maybe Borja, you can start here again. What do you think?
So that's a difficult question. It depends on it's difficult to say. I mean, definitely there's a first part, which is the experimentation and the Python, but then translating that into a production model, you really need to do a lot of work. You really need to do like some development there. So, but then there's this experimentation environment that you need to set up, and you cannot minimize the effort that you need to do in order to create that environment, because there are many tools available. There are cost considerations taken into account, and you really want to make it easy for your data scientists to experiment well, and you want to be able to do it. So I would say it's 50-50, because also, I mean, just creating the Python code that Martin had to work, it took him like a couple of weeks to do it. So yeah, it's around 50-50, and we would need more time for monitoring. We would need more time for Kubeflow. So it could even be more. It could even more like 60 MLOps or ML/MLOps, and then 40% the rest, I would say.
Any other thoughts, Yanni, Martin?
I think the DevOps part is good as a basis. If somebody comes to the MLOps with the DevOps knowledge, then everything goes much faster, much smoother. I remember in the beginning when we didn't know each other, it took me and some other students hours and literally hours to do stuff that Borja or Christian, another DevOps guy, were doing in 5 minutes. So, you know, that's an advantage. But once you are there and the machine learning kicks in and you start using tools like Kubeflow, so the DevOps advantage in a way disappears. So it's a whole mix there.
Yeah. Yeah. So I'd like to bring this other question that Kumar threw out there into the mix here, because I know Yanni and Martin, you're both a lot more comfortable in the modeling, in the notebook, doing the ML, doing the deep learning. And, you know, Kumar asks how much ML or DL experience is sufficient to master this course? Maybe Martin, you can start off with this one.
I think, it depends, right? Because we can have the different views in here. On my side, that was like my area of expertise, so it was really helpful, right? And it depends. I think that for answering that question, it depends on what you want to achieve, right? So, for example, in my end, maybe I don't want to become an MLOps architect. Maybe, you know, like this is just the gap that I need to break between my data science knowledge and how to deploy. But for example, the other way around Borja, like Borja was much more stronger on the DevOps side and he wanted to learn how to learn the ML side. But I would say, you know, like feeling comfortable with training a model, understanding a little bit of TensorFlow, PyTorch, like these libraries is really going to help you to join this cohort.
Yanni, what are your thoughts on this? You came in as an expert on modeling. You were a resident expert.
Yeah, it's like I'm from the math side. I didn't even write code. I used to sit with a pencil and a paper. So it's but you know, it shows you in a way. I would answer to the question that even with zero knowledge you can do it. Why? Because when you look on the three of us, it's completely different knowledge on different areas. Borja came practically with almost, I think you will excuse me for saying this, but almost zero knowledge of machine learning. I mean, like when I talked about transformer, he was like, you know, what is it? So he could do it, and now he understands and he can implement. And I'm the other extreme. What is DevOps to put up a virtual machine in AWS or GCP was like mind blowing, but now it's a matter of minutes. So I would say if you really want hard to work hard and you have determination, you can come with almost zero knowledge and make it.
Also the team, no? Creating the team, having a complementary team like we were talking about in the beginning of the presentation, that's become critical, no? So we can complement each other. And this for me, this is the most valuable thing about the course. You engage with people that is working on ML, that is trying to implement things, and yeah, you can complement what you don't know with other people's. And this team, for example, was really complementary, and there was a good chemistry, which was critical. But learning from each other is being very important to achieve this.
And Borja, can maybe you comment on sort of your transformation from, let's say, approximately zero ML DL knowledge to where you are today, and how you feel sort of on that front after taking.
First, I still feel very far away from Johnny and Martin in terms of ML. The second thing is that, well, when you are in your area in DevOps, you or in other parts of technology, you're working in your area and that's it. But this has forced me to have discussions about machine learning, to have discussions about MLOps, and this is moving me forward. I learn new things every day. When I talk to Martin and he tells me, hey, you don't need Kubeflow, you can use DVC and Git and GitHub, and then you can have all your experience. I'm like, what? This is new. I didn't know about it. So every day there's something new. And talking to these guys, I'm learning a lot. So yeah, I'm still in progress. Let's put it that way.
Nice. Okay. Yeah. And so, Martin, I wonder if you sort of agree with Yanni. I mean, we have Duke's asking a question about the learning curve. Hey, like, I'm not experienced with DevOps, but I'm interested in this course. What is that learning curve like? Obviously, Yanni, we saw him, he had the mindset, he was ready to get after it from day one. Can you talk a little bit about your experience as well, coming in as a data scientist?
Yeah, no, totally, but definitely agree with Johnny. And like, you need to, I think that you can take it easy with the cohort, right? Like, take it easy, like, just attend to the classes. But if you really want to take it into the next level, you need to dedicate the time, right? Like, you need to dedicate those 10 hours that we were putting on the week, assisting like to the spaces with the teachers and the other team members to really learn about each other. So I think it depends on the amount of effort that you want to put. But again, like, I think on my experience, yeah, like, I joined it knowing how to model, but now I felt comfortable Dockerizing, launching Kubernetes, using virtual machines, deploying services. So yeah, it depends on the amount of effort that you want to put.
Okay, great. Yeah, I want to kind of start wrapping up this question period with Eric Peterson's question. It's a great question, and it's relevant to anything that we do in the future, fourth brain at forestry. I guess I'm going to throw it out there to whoever wants it. How do you measure the quality of the AI solution for at Forestry's AI MVP product that you've built here? How do you measure quality?
That's a perfect question, and I'm gonna go back to my learnings from the MLOps course. You need to measure it from two sides, right, Greg? Of course, your business KPI, like what is that KPI that you need to track? But of course, let's say like the deep learning or machine learning KPI that we want to use. So the ones that we were benchmarking to was the F2 score, which on Kaggle, it was getting like 92%. And we were able to get like 91. So it was a quite decent score. So, but as you have seen, like, you cannot rely only on that single score. You need to really implement all of these MLOps concepts of continuous monitoring, making sure that you are testing. Here, you're going to learn a lot of not only monitoring from the system and quality perspective of the infrastructure, but also the quality of your model, right? Like, is the data that you are receiving is the same data that you were expecting, or something has changed? So you learn how to implement like these controls using different tools like Grafana, Prometheus, to make sure that your model is still up in quality and you're continuously monitoring.
That's really something that is special with the ML. That's why it's not DevOps. It's not that you build something and it's going to work fine for the next 5 years. No, there is drift. The model is drifting. The data is drifting. You need continuous monitoring, even if it works well with all the statistical benchmarks in the beginning. So, and that's stuff that you learn, and you learn in the course.
I love that. So I guess the place to wrap up is that the quality is going to continue to improve as we continue working together on this open source project that we're very excited about. There's opportunity for modeling, there's opportunity for infrastructure work, there's opportunity for another amazing team or more to come in and contribute to at forestry and saving the planet's forests one scan at a time. And so, we're really excited again, guys, to be working with you on this. And what I'd like to do now is, for everybody that's still sticking around, I'd like to pivot over and tell you a little bit about the curriculum before we close, and we'll have the speakers come back up so we can say thank you to them in just a few minutes. But I want to show you, if you're still into it, exactly what you'll learn if you take the upcoming MLOps cohort. So what we're looking at for this cohort is we're looking at the same kind of standard 10-week program structure that we've laid out in the past few. And we've decided to go Tuesdays and Thursdays, 4 p.m. to 7 p.m. Pacific time. And if you spend about 10 to 15 hours a week, again, as you heard from our speakers, you could spend a lot more time. But if you spend this much time, then you should be able to accomplish most of the goals that you come into the program aiming at. And at least you'll get started down the path to MLOps. The big takeaway from this course is that you're going to come in, you're going to have some baseline machine learning and deep learning skill sets. But from there, what we want to do is want to focus critically on deployment. And then once we deploy to production, we want to make sure we're monitoring the appropriate metrics, we're logging the right information, we're collecting the right data from our users while we are in production. From there, we want to make sure that based on that monitoring and everything that we're looking at, we trigger retraining and improvement automatically. And finally, in the course, we will also talk about if and when that user base increases, if and when you need to scale out hardware or other aspects of your infrastructure, exactly how you might do that with services today. So the 10 weeks of the course, they go through, first off, the AI product lifecycle. In sort of a big picture way, we scope the problem, we make sure we're working on a problem that's worth solving. And to sort of address one of the other questions we got today about the program having predefined projects, yes, the program does have predefined projects. At Forestry will be one of them. However, we also encourage you all to do the hard business value work of thinking about what problem is worth solving the most for you, and do that ideation within the first week, whether you end up working on that project or not, because that's where you really are going to be able to make sure that you're working on the right thing to create business value for whatever company that you go work for next. And that's based on talking to our hiring partners, what every company wants in the ML practitioners that they're bringing on board in 2022. So we want to have the big picture in mind as we go into the details of the infrastructure, looking at levels of automation in week 2, diving very deeply down to the nitty-gritty syntax level of ML web applications, and then talking in excruciating detail about like what's the deal with containers, because they form the basis for a lot of what we do later in the course. When we talk about serving our models and the infrastructure that's required, not just for the models, but for the data, that comes next. And then also how we manage models that have been deployed, that have been served up. Now we're dealing with lots of model versions. How exactly does this look on the back end? Once we kind of have this data and model version control within a production environment down, we really take a very hard look at model monitoring. So logging and metrics and all of that, we take a hard look at, including the open source tools, Prometheus and Grafana. Then we get to scaling deployments. This means horizontal scaling, vertical scaling, all the scaling that you can think of, before we talk about some of the nice tools that are coming out today, both open source and managed services, that allow you to create pipelines end to end, or even just smaller workflows that allow you to streamline your work. And all that leads up to the final demo day in week 10, where we will discuss sort of continuous integration, continuous deployment, full stack MLOps in the cloud. So what this looks like in terms of a tools perspective is you're going to come in, you're going to get set up. You're going to get set up with an interactive development environment. And a quick shout out, we're going to do an event on this next month. So look out for that on how to get set up. The cloud computing on-ramp is also something that you come in essentially set up on. So we're going to give you your own AWS account, and you're going to be able to leverage cloud credits directly based on your tuition. So from day one, you're set up, ready to rock and roll. From there, you're going to learn some of the most important tools that have become industry standards. And we're going to focus, because we believe focus is key, we're going to focus on the AWS stack. And we're going to focus on one tool at a time in each category so that we can really drill down to the first principles and see how we apply them. From there, we're sure that you're going to be able to apply any tool that you'd like. So we look at Hugging Face, including all of their tool sets. We look at, first off, we dig right into what a full stack ML product is actually looks like on the front end of the user. So that's SageMaker, that sort of abstracts all of the infrastructure away. We're going to look at how that connects to Hugging Face. Then we look at how to build pipelines with AWS Lambda, how to serve those up through API Gateway, and how to look at what's going on with CloudWatch. We do this very, very early so that you understand what end-to-end ML MVPs look like before we get into scaling. From there, we dive deep again into web applications and containers, including how AWS supports container technology. And then we heard about NVIDIA Triton Server early as a place that maybe these guys want to go. That's a tool that we dive deep into. Of course, there are many different serving technologies. We cover those as well, but that's the one we're going to get hands-on with. We can leverage AWS to make that even easier for us. And then when we talk about data and version control, we are going to keep it industry standard with DVC and also Databricks. Their MLflow open source product has become the industry leading model management tool set. So MLflow tracking, MLflow projects, MLflow models, and MLflow model registry. Of course, when we talk about monitoring, Prometheus and Grafana are sort of the visualization and the data collection mechanism that we need to monitor anything that we need. While we will use CloudWatch, we'll also look at the open source tools. So generally, we're looking at managed versus open source along the way. Everybody wants to understand Kubernetes. The way to do that is to start with local Kubernetes called Minikube. And then the way to really implement it is to use a managed service like AWS EKS. So that's what we're going to do before we dig into what pipeline flows look like. So that's Kubeflow, and Kubeflow is also on managed services as well. And then we're going to get into continuous integration delivery with GitHub Actions. So the other interesting, awesome opportunity that we're going to offer in this upcoming cohort is we're going to do community sessions with another previous MLOps grad, Robin. And he's going to run community sessions regularly for both career seekers and domain experts interested in entrepreneurship. Robin was fortunate enough to be one of these students that sort of left the program and got everything he wanted. So, he was looking for a career move and he was looking for how to build a startup. He managed to do both. And, I'm happy to announce he's got his new gig. He's got funding for his side project and he is rip-roaring ready to go. And he is also more than excited to support our community. So we are blessed to have him on our team. And if you're interested in getting a new job or going from 0 to 1 with your own company, this is going to be a great opportunity for you outside of our 2 weekly live sessions. So if you're interested in joining and you want to learn more, one of the things that you can do is you can make sure that you're ready to go for your application, because what we're going to ask for is we're going to ask for a GitHub repo or some sort of public web application that you've developed. Now, if you don't have a GitHub repo or public web app that you want to share with us yet, we have some really straightforward ways for you to go create one if, as we heard from Yanni and Martin, you're ready to go get after it. So, if you submit your online application, you'll get access to exactly what our recommendations are in terms of what we'd like to see submitted so that you're ready to go day one in MLOps. And if you need to do a little bit of work on the front end this month before we get started, you will have time for that before a start date on September 13th. So class starts on the 13th. Tuition for this program is $6,000 US. That is including the cloud credits that you'll need to build your Capstone project. And so if you're interested, please go to www.fourthbrain.ai/apply. And you can always email us at info@fourthbrain.ai.com. So that's it for curriculum. I'd like to go ahead and invite our speakers back up onto the stage for a brief sign off. So thank you everybody in the audience for all of the great questions. Thank you again, Martin. Thank you, Borja. Thank you, Yanni, for joining us today. Technical difficulties and all, we really do appreciate it. It's been a great session. This brings us to the end of today's event. So out there, we hope you've enjoyed it and that you've learned a lot about who you could meet and what you could build in just 10 weeks during our upcoming MLOps program. For more information on that upcoming MLOps program, which launches September 13th, again, check out fourthbrain.ai, where you can also find information on our machine learning engineer program, as well as our corporate training offerings for both MLE and MLOps. Finally, if you'd like to follow up with any of the speakers that you noticed in the YouTube chat, or anybody that you noticed in the YouTube chat, you can find them on LinkedIn and send them a message. And if you have any additional questions that we did not answer today regarding our MLOps program, feel free to reach out to me directly at greg@fourthbrain.ai. That's it for today. We look forward to bringing you more interactive demo events directly from our amazing graduates soon. Good luck as you continue your own personal learning journey into production ML, also called MLOps. Thanks, everyone. See you soon. You're clear.